Sour gas, or feed gas, which contains H₂S and or CO₂, will pass through the inlet separator and enter the amine contactor, also sometimes referred to as an amine absorber. The sour gas enters the contactor from the bottom and flows upward, while lean amine, a mixture of amine and water, enters at the top of the tower and flows downward. The amine reacts with acids and absorbs them from the gas stream until the gas exits from the top of the contactor. The gas then enters an outlet separator to remove any amine that might have carried over from the contactor. Once any carried over amine has been separated from the gas, it is now referred to as sweet gas or treated gas, the opposite of sour gas, as it no longer contains H₂S and or CO₂. The amine solution exits from the bottom of the contactor as rich amine, now containing the H₂S and or CO₂ absorbed from the sour gas. The rich amine will then flow into a low-pressure flash tank. The low pressure of the flash tank allows entrained light hydrocarbons to flash off of the amine solution before it goes to the regenerator. The rich amine enters the lean-rich exchanger and enters the regenerator. From the outside, the regenerator resembles the amine contactor, as they are both tall, vertical towers. The rich amine enters near the top of the tower, below the top few trays or layers of packing, as the top of the regenerator is used for reflux water. The reflux section captures vaporized amine that may travel upward with the steam. The regenerator works at high temperature, low pressure, which could in theory lead to the vaporization of some amine. The rich amine enters below this reflux section and flows downward, contacting the steam that flows upward. The goal for the regenerator should be to drive 95% or more of the acid gas from the amine before it reaches the bottom of the regenerator and enters the reboiler, where the steam is generated. Very little H₂S and or CO₂ can be left in the amine, as the acid gases are very corrosive to the reboiler. A regenerator will usually contain 20 to 25 trays, or the equivalent height in packing. The internals could be random pack or structured packing, just like the contactor. In a thermosiphon reboiler, the amine enters at the bottom and is boiled. The solution returns in one single pipe with two-phase flow. Both the liquid and the vapor enter the regenerator. The steam travels upward as the liquid falls. There are many ways to power the reboiler. The reboiler can be heated using hot oil, glycol, direct fire, or low-pressure steam. For vertical thermosiphons that use low-pressure steam, the steam enters the shell side and is condensed into water as it transfers heat to the amine. This method effectively uses steam to create steam. The operator is able to control the flow of the low-pressure steam, but it can be difficult to tell how much steam is being generated in the reboiler, as there is no flow meter going into the regenerator. There are common methods to determine if enough steam is being generated. This will be further covered in the operations section.